Hi everyone, myself is Annapurani, Department of Mathematics, K.S.Rangasamy College of Technology, Tiruchendur. Today my topic is Isomorphism of Graphs from graph theory. Everyone know about graph. Graph contains vertices and edges. Now we have to see the definition of isomorphism of graphs. The definition is the simple graph. I hope everyone know about simple graph. The simple graph does not contain self-loop, parallel edges. Here we consider only simple graphs. We have to take two graphs. G1 that contains V1 vertices, E1 edges, and G2 graph it contains V2 vertices, E2 edges are isomorphic if there is a one-to-one and onto function f from V1 to V2 with the property that A and B are adjacent in G1 if and only if f of A and f of B are adjacent in G2. For all A and B in V1, such a function f is called a isomorphism of graphs. Next, let us know some conditions for isomorphism. How to find out the isomorphism? By using those conditions. First condition is if G1 and G2 are isomorphic, then G1 and G2 have same number of vertices. Both the graph should contain same number of vertices. And the second condition is the same number of edges. And another one, an equal number of vertices with given degree. Those above three conditions are not sufficient for graph isomorphism. This is one of conditions. Next. Let us see two types of problems. First problem is determine whether the graph G and H given below are isomorphic or not. Here given two graphs G and H. First G graph contains U1, U2, U3, U4, U5, U6, 6 vertices, and H graph contains V1, V2, V3, V4, V5, V6, 6 vertices. Next, the given graphs are, we have G and H graph. First let us take both the graphs contains same number of vertices. In G group or G graph also contains 6 vertices, H graph also contains 6 vertices. And counting the edges, we have 7 edges. So same number in graph G also contains 7 edges, H also contains 7 edges. So both the graphs contains same number of vertices, same number of edges. Next, moreover, in the graph U1, U3, U5, U6 are of degree 2 each. See the G graph. In G graph U1 have 2 degree and U3 also have 2 degree, U5 also have 2 degree and U6 also have 2 degree each. And U2 and U4 are degree 3 each. See the G graph, U2 contains 3 edges, so the degree is 3, and U4 also contains 3 edges, the degree also 3. Now compare the G graph with the H graph. H graph also contains same number of vertices and edges. Now see the degrees. Similarly, see the V4 graph, V4 vertices. V4 vertex contains 2 degree, V6, V1, V2 also have a degree 2. And each V3 and V5 are of degree 3. Now compare both the terms, then we get one correspondence like, see, f from graph G to H defined by f of U1 is equal to V6. Then f of U2 equal to V3. U2 of degree and V3 of degree also same. Likewise, f of U3 equal to V4, f of U4 equal to V5, f of U5 equal to V1, f of U6 equal to V2. Then here f is bijective. Bijective is nothing. It satisfies one-to-one correspondence and onto. So and also adjacency is preserved. So here both the graphs contains satisfies every conditions. Therefore, the G and H are isomorphic. Let us see the another one problem. Here, determine whether the graphs G and H given below are isomorphic. Here, I gave the two graphs. One graph is G and another graph is H. G graph contains A, B, C, D, E, F, G, H vertices, and H graph contains U, V, W, X, Y, Z, T and S vertices. Now we have to check the vertices, how many vertices and how many degrees. Both the vertices and degrees are same or not. Okay, let us see. Both the graphs G and H have the same number of vertices. In graph G, it contains the 8 vertices, and graph H also contains the 8 vertices. Next we have to check the edges also. Edges also same. Both the graphs edges also 10 edges. So next you have to check degree of A. Here degree of A is in graph G, degree of A is 2. A must correspond to either T, U, X or Y in H. In H graph, let us see H graph, because these are the vertices of degree 2. In H graph, U, T, X, Y only contains degree 2. So A must correspond to T or U or X or Y. Now let us check that. However, each of these 4 vertices in H is adjacent to another vertex of degree 2 in H. Let us see from the graph H, degree of T vertex is 2, but T is adjacent with S and T is adjacent with U. T adjacent with S vertices, it contains degree 3, and T adjacent with U, that degree is 2. Now compare with A. From the G graph, A vertex is degree 2. This is adjacent with B and adjacent with D. A vertex adjacent with B, but it contains the degree 3, and D also contains with the degree 3, but this is not satisfied with the H graph. So this is not. Therefore, finally you can get which is not the true for A in graph G. And here from those conditions, G and H are not isomorphic. Thank you.